In this video, we'll go over the slides for the geometric and spatial reasoning section that is on the TSIA math. Take a moment to look at these vocabulary words. If you're not familiar with some of them, look them up. Proportions. Triangles ABC and DEF are shown above. Which of the following is equal to the ratio BC over AB? Before you look at any of the answer choices, you want to redraw the triangles like this, so that the 32 degrees corresponds with the 32 degrees right here. So that means that A corresponds with E, B corresponds with D, and C corresponds with F. So on this one, if we have BC, that should correspond with DF. And then AB would correspond with ED. Now, ED could also be rewritten as DE. Those would be the same line segment that they're referring to. So the answer is answer choice B. Here's another proportions example. 45 of the shoppers purchased D. How large is the sector angle for D? This pie chart shows the market shares of 5 brands of cleaner, based on a survey of 300 shoppers in New York. So if there's 300 shoppers altogether, and 45 of them chose D, if we want to change that into degrees of a circle, we have 360 for the full circle. And we're looking for the value, and we'll call it X. From here, you would cross multiply the 360 times the 45 and the 300 times the X. You get 16,200 equals 300X. Divide each side by 300. And then you get 54 will equal X. So the answer would be 54 degrees. As a salesperson, your commissions is directly proportional to the dollar amount of sales you make. If your sales are $800, your commission is $112. How much commission would you earn if you had $1,400 in sales? We would set this up as a proportion. 800 over 112 equals 1,400 over X, where the numerator is representing the sales revenue and the denominator represents the commission. Cross multiply. $800X equals 156,800. Divide each side by 800. And then you should get X equals 196, which is answer choice B. Running at an average rate of 6 miles per hour, how many minutes would it take Kyle to run 3 miles? Now, let's remember that 60 minutes is equal to 1 hour. So instead of per 1 hour, we're going to put per 60 minutes. In the numerator, that's going to be miles. The denominator is minutes. We're going to cross multiply. 6x equals 180. Divide each side by 6. X equals 30. That's answer choice B. Try this one on your own. According to the Department of Agriculture, consuming 100 grams of bananas provides 0.15 milligrams of zinc. Which of the following is closest to the number of milligrams of zinc provided by 140 grams of banana? Pause the video and try this. When you're ready to check, unpause the video. You would set up your proportion like this. We'll have one side of the fraction be grams of banana and the other be the milligrams of zinc. Cross multiply. And then you get answer choice B, 0.21. Types of angles. Acute, an angle measuring less than 90 degrees. Obtuse, an angle measuring greater than 90 degrees. Right, an angle measuring 90 degrees. Straight, an angle measuring 180 degrees, a straight line. A full circle is 360 degrees. Here's an example of what each of those angles look like. Complementary angles are two angles that have measures that add up to 90 degrees. Supplementary angles are two angles that have measures that add up to 180 degrees. If the angle of measure 1 and the angle of measure 2 have measures of 72 degrees and 28 degrees, they are complementary, because 72 plus 28 equals 90 degrees. If angle 3 and angle 4 have measures of 134 degrees and 46 degrees, they are supplementary, because if you add together the two values, they give you 180 degrees. Try these two examples, the supplementary angles example and the complementary angles examples. In the figure below, BAC measures 30 degrees, ABC measures 110 degrees, and points B, C, and D are collinear. What is the measure of angle ACD? In the figure above, point B lies on line AD. What is the value of 3x? Pause the video, try these. When you're ready to check, unpause the video. To find this, first we label all of our given degrees, and we want to find this angle eventually. To find this angle first, we're going to have 180 minus 110 minus 30. That gives you 40 degrees. And then to get the question mark, 40 and this are supplementary. 180 minus 40 would give you 140. That's answer choice G. We know that x plus 2x plus 2x would equal 90 degrees, since the other side is 90. 5x equals 90. Divide them by 5. X equals 18. Now that's what x is, but it wants to find 3x. That's 54. So the correct answer is answer choice C, 54. Types of angles. When a pair of lines intersect, they form two pairs of vertical angles. In the figure below, angle 1 and angle 2 are a pair of vertical angles. Also, angle 3 and angle 4 are a pair of vertical angles. It's good to remember that vertical angles are always congruent, that is, in identical form. That basically means that angle 1 and angle 2 are the same number, and angle 3 and angle 4 are the same number. Here's an example. Find the value of x and the measurement of the angles labeled in the picture below. We have 9x minus 18 and 6x minus 3. Set them equal to each other. Solve for the x. You get x equals 5. To get the angle measurement, you'll plug 5 into one of the expressions. 6 times 5 is 30. 30 minus 3 is 27. Now let's just say we want to get this angle instead. That would be 180 minus 27. And that would be 153 degrees. Try this example on your own. What is the value of y? Pause the video and try this. We are ready to check. Unpause the video. First, find what x is by saying these two angles equal to each other. Evaluate into the angles you get 40 degrees. To get y, it's 180 minus 40. Y equals 140 degrees. Degrees versus radians. Just like percentages need to be converted into standard form, decimal, to be used in a formula, degrees must also be converted into radians to be used in a formula. A common example is circumference equals 2 pi r. You would not write this as c equals 360 degrees r. To convert from degrees to radians, a good thing to know is that 180 degrees equals pi radians. This relationship is handy for converting. We have the proportion degrees over 180 equals radians over pi. Here's an example. Convert 120 degrees to radians. Plug in 120 for the degrees. Cross multiply. To get radians, it's just 120 pi over 180. Simplify those fractions. They both go into 10. They both go into 6. So they have 2 over 3, and they have that pi. We're simplifying the fraction. You can leave out the pi until you're ready to write your answer. Usually they want exact numbers and not just 3.14, unless it specifically says it's to round. Try this one. To convert from degrees to radians, we know that it's 180 degrees equals pi radians. Convert 45 degrees to radians. Pause the video and try this. We are ready to check. Unpause the video. "45 degrees is equivalent to pi over 4 radians. Relationship between number of sides is sum of interior angles For regular polygons, all interior angles are congruent. Angles and polygons. A certain polygon has interior angles of 135 degrees. How many sides does it have? The formula for the sum of interior angles in a polygon is n minus 2 times 180, where n is the number of sides. We are looking for n, the number of sides. We can start by writing an expression for a single angle in the polygon. The sum of interior angles is n minus 2 times 180 degrees, and there are n sides, so to find a single angle, we divide the total number of angles. Partway through, we drop the degree symbol for simplicity. So we set up our equation, n minus 2 times 180 degrees over n equals 135 degrees. Multiply each side by n to get rid of the fraction. Distribute the 180 into each of these two terms. From there, we want to add 360 to both sides, and then subtract 135n from each side. And then we get 45 times n equals 360. Divide each side by 45, and then n equals 8. So that means there are 8 sides to this polygon. This is known as an octagon. Transformations. Describe the changes in a shape over a time duration. Rotation. In a rotation, the figure is turned around a fixed point. In this figure, triangle ABC is rotated 90 degrees about the point 0, 0 to the new position A', B', C'. Reflection. A reflection flips the figure across a specified line, called the line of reflection. Quadrilateral ABCD is reflected across the y-axis to A', B', C', D'. Dilation. A dilation preserves the size of the angles but changes the length of sides by the same proportion. This effect is to shrink or enlarge the figure. Triangle ABC has been dilated to form triangle DEF. The reverse is also true. Translation. In a translation, all of the points are moved in the same direction and distance, as if it were slid across the plane. Triangle ABC is translated to triangle A', B', C'. Match these. Draw a line connecting the matching terms with descriptions. Pause the video, see if you can match each of these terms and descriptions. Here's the terms and descriptions solutions. A rotation spins the image. A reflection is a mirror image. Dilation resizes the image, and translations moves the image. Special right triangles. We have the 45, 45, 90 triangle, where the legs are the same length, both x, and the hypotenuse, the longest side, is x times the square root of 2. Hypotenuse is just the longest side. For example, what is the hypotenuse of a 45, 45, 90 triangle when the legs are 5 square root 8? 5 square root 8 is equal to x, so if we multiply each of these by square root 2, we then have 5 times the square root of 16 equals x squared root 2. Square root of 16 is 4, and 4 times 5 equals 20. We also have our 30, 60, 90 triangle, where the opposite of 30 degrees is x, the longest side, the hypotenuse, is 2x, and then the side adjacent to the 30 degrees is x squared root 3. Example, what is the shortest side of a 30, 60, 90 triangle when the hypotenuse is 50? That means that we have 50 equals 2x, and we're looking for x, so divide these by 2. 25 equals x. You could check these with the Pythagorean theorem, a squared plus b squared equals c squared. Alright, try this one. What is the side opposite of 60 degrees of a 30, 60, 90 triangle if the side opposite of 30 degrees is 8? Pause the video and try this out. We are ready to check. Unpause the video. The answer is 8 square root 3. Since the side opposite of 30 degrees is 8, the side opposite of 60 degrees would be 8 times the square root of 3. Trig functions. We have a right triangle. The opposite to angle T is called the opposite side. The longest side is the hypotenuse, and the adjacent side to T is this side right here. We have sine of T is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent of T is opposite over adjacent. Commonly, they refer to the opposite side as y and the adjacent side as x. The hypotenuse would be the radius. If it's a unit circle, the radius is 1. Given one side and one acute angle. If you have a right triangle in which you're given one side and one acute angle, you can find either of the other two sides using a trig ratio. Calculate the length of the hypotenuse in this triangle. From the point of view of the 24-degree angle, 15 is the opposite leg, and x is the hypotenuse, the longest side. You will need to use the sine function in this problem. Sine of 24 degrees equals the opposite over hypotenuse, 15 over x. X will equal 15 over sine of 24 degrees. From there, if you're allowed to use a calculator, you would plug that in. Make sure that the calculator is in degrees. By default, the calculators are usually in radian mode, so you'll want to go to settings and click on degrees. if you're evaluating such formulas. Try this one. Find the side length x. Pause the video and try this using the trig functions. When you're ready, you can pause the video and check. You set up your equation in terms of sine. Solve for x. We have the exact answer of 9 over sine of 42 degrees, and it's approximately 13.45. Now, you could also do this in terms of cosine. It would look like this. Since you're not given the 48 degrees, it would be quicker to do it in terms of sine. Given two sides. If you have a right triangle in which you're given two sides, you can find either acute angle using a trig ratio. Calculate the measure of angle B to the nearest degree in this triangle. From angle B's point of view, 9 is the opposite leg and 15 is the adjacent side. We will need to use the tangent function for this problem. Tangent of angle B is equal to 9 over 15, opposite over adjacent. Tangent of angle B is 0.60. Use a calculator to find the inverse tangent of 0.60. That's 31 degrees. You could write it either as this. You also might see a notation that looks like this. So note, tangent inverse is the same thing as arc tangent. It is the inverse trig function used to find angles. It is not the reciprocal. Cotangent is the notation for the reciprocal of tangent. So this is not 1 over tangent. 1 over tangent is cotangent. Try this one. Find the angle, measure x. Pause the video and try this. We are ready to check. Unpause the video. Angle x is approximately 21.04 degrees. We set this up with tangent of x equals opposite over adjacent. The opposite of angle x is 5, the adjacent is 13, and the longest side is the hypotenuse, which we don't need in this problem. To get the x by itself, we will take the arctangent of each side of the equation. If we plug that into a calculator, we get about that 21.04 degrees. Keep practicing these geometry and trigonometry concepts with more worked problem videos. Try the worksheets, do the other games, and then look at the other sections to get ready for the TSIA math. Good luck on these.